Hello friends, today I am going to ask you a question that will break down all the walls of your thinking. Can you ever pass through a solid wall? Meaning, without opening a door, without making a hole, without using a hammer, just walk and disappear into the wall, like a ghost. Right now you might be thinking, this guy is talking crazy things. But wait, physics, especially quantum mechanics, which is the law of behavior of the smallest particles like electrons, protons, photons, says yes, you can pass through. But there is a condition. And that condition is so strange that Einstein himself said, God does not play dice. He couldn't believe it. Today I will explain to you in simple language with real-world examples how, when, and why a particle can pass through a wall. And the biggest question, can you, a human being, ever do that? You might be surprised to hear this, but inside your body, every second, billions of electrons are tunneling through walls, without you even knowing. Yes, this is true. And that's what we will understand today. So get ready, pick up your pen if you like taking notes, engage your mind, and let's begin. First, let's understand what old physics, which we call classical physics, says. This is the physics that applies to our everyday life. Ball, car, stone, our body. Suppose you take a tennis ball and throw it hard against a solid wall. What will happen? The ball will hit the wall and bounce back and maybe fall to the ground and roll. There will be no hole in the wall won't even move. Why? Because the wall applied force on the ball. According to Newton's third law, every action has an equal and opposite reaction. The ball applied force on the wall, and the wall applied an equal force back on the ball, pushing it backward. In physics, this wall is called an energy barrier. The ball has a certain kinetic energy of motion. The wall has potential energy, which keeps the wall solid. When the ball's kinetic energy is less than the wall's potential energy, the ball bounces back. If the ball's energy is higher, it can break the wall. But even then it doesn't pass through, it destroys the wall. Now think about yourself. You are a 70-kilogram human. In front of you is a 1-foot thick solid concrete wall. You run and try to go through it. What will happen? Your nose will break, your head will crack, your bones will shatter. But the wall will remain as it is, because your kinetic energy, even if you run like Usain Bolt, is very small compared to the wall's potential energy. This is classical physics. This is our common sense. And so far, everything was fine. But, at the beginning of the 20th century, something was discovered that turned this entire common sense upside down. That was quantum mechanics. Particles are not just particles, they are also waves, and waves pass through walls. Friends, have you ever seen water waves in a pond? You throw a stone, circular waves form and spread far. Now suppose a thin wall, like a plastic sheet, is placed in the path of these waves. You would think the waves will stop, but that doesn't happen. The waves pass through that wall, their intensity, height reduces, but they reappear on the other side. This phenomenon in physics is called tunneling. The wave creates a tunnel, without making a hole. Now the most interesting thing, in the quantum world, every particle is also a wave. This is called wave-particle duality. An electron, which always seems like a tiny ball, actually has a wavelength just like a light wave. When this electron wave hits an energy barrier, a wall, classical physics says it should stop. But quantum mechanics says, no, the wave decays rapidly inside the barrier, and if the barrier is very thin, it reappears on the other side. Exactly like you digging a tunnel through a mountain, and coming out the other side without climbing over. That's why it's called quantum tunneling. Now think, if you were an electron, you could pass through walls billions of times every second. But you are a human, so what? I will answer that later. First, let me tell you where tunneling actually happens in real life, and how it affects your everyday life. Now let me give you 3 real-life examples where nothing would be possible without quantum tunneling. First example, the sun. You see the sun rising every morning. Where does its heat and light come from? Inside the sun, nuclear fusion happens. 2 protons of hydrogen collide to form helium, and in this process, a huge amount of energy is released. But there's a problem. Both protons are positively charged. According to classical physics, 2 like charges strongly repel each other. They cannot even come close, let alone fuse. So how does fusion happen? Because of quantum tunneling. Protons tunnel through each other's Coulomb barrier, the wall of electrical repulsion. If tunneling didn't exist, the sun would never burn. No heat, no light, no life on Earth. So next time you sit in the sunlight, remember, you are getting warm because of tunneling. Second example, your smartphone. The transistors and flash memory inside your phone work on the principle of tunneling. In flash memory, electrons tunnel through an oxide layer, a barrier, and get trapped in a floating gate. And that's what stores your data, photos, videos, messages. Without tunneling, neither USB drives, nor SSDs, nor your computer would work. So when you press the like button, billions of electrons are passing through walls. Third example, your DNA. Yes, every cell in your body has DNA. And proton tunneling happens inside it. Between the two strands of DNA, there are hydrogen bonds. Sometimes a proton tunnels through the barrier of that bond and moves to the other side. This causes mutations, genetic changes. Some mutations are harmful. Diseases like cancer. Some are beneficial. That is the root of evolution. So the way you look, your eye color, your height, some of these things are gifts of tunneling. So you see, tunneling is not a distant fantasy. It burns the sun, runs your phone, and changes your DNA. Now, to see tunneling with your own eyes, I will do a simple experiment. This experiment is not actual quantum tunneling. For that, you need an electron microscope. But this is an analog experiment that shows how waves can pass through a barrier. I take a glass of water, add 2 to 3 drops of milk. It becomes slightly milky. I added milk so that the laser beam becomes visible. I turn on the laser pointer. The beam goes from one side of the glass to the other. You can see it. See, the laser light is passing straight through the water. Now, on the outside of the glass, in the middle, I draw a black line with a marker, about 1 centimeter thick. Now I have made a black strip on the glass. This is a barrier. You would think the laser light will stop here, because black color absorbs light. I turn on the laser. The beam hits the black strip, but on the other side a faint red glow is visible. Look, some part of the light has reached beyond the black strip. Very weak, but it has reached. This is optical tunneling. Exactly like how in the quantum world an electron passes through a barrier. Now you must be thinking, sir, that's fine, but when can we humans pass through a wall? Let's answer that question now. Friends, now we have arrived at the most important question. Can you, a 70 to 80 kilogram human being, ever pass through a solid wall? The direct answer from quantum mechanics is, mathematically, yes. Practically, almost impossible. Let me explain without formulas. The probability of tunneling depends on 3 things. 1. Your mass. Lighter is easier. An electron's mass is 9.1 times 10 to the power minus 31 kilograms. Your mass is about 70 kilograms. That means you are 10 to the power 32 times heavier. 2. The thickness of the wall. For electrons, the wall is nanometer thick, 10 to the power minus 9 meters. For you, a 1 foot thick wall. That is 10 to the power 8 times thicker. 3. The difference between the wall's energy and your energy. For you, this difference is huge. When you combine these 3 and calculate the probability, the result is approximately less than 10 to the power minus 100. That means a decimal point, then 99 zeros, then a 1. That number is so small that the chance of tunneling even once in the entire age of the universe, 13.8 billion years, is nearly 0. So brother, if you wake up tomorrow and bang your head against a wall, your nose will break, not tunneling. But, and this is a big but, is it possible in the future? Scientists are researching macroscopic tunneling. If ever we can turn a large object into a Bose-Einstein condensate, the 5th state of matter near absolute zero, then theoretically it might be possible. But for now, it's just a dream. That doesn't mean we give up hope. Science is moving forward. Now let me give you 2 more very important examples where quantum tunneling is used in everyday science. First example, scanning tunneling microscope, or STM. This is the instrument with which scientists can take pictures of atoms. In STM, there is a very thin needle that hovers just above a surface. A small voltage is applied between the needle and the surface. Electrons tunnel through that tiny gap, which is a barrier, from the needle to the surface or surface to needle. By measuring this tunneling current, a computer maps the positions of atoms on the surface. Using this technique, scientists first arranged iron atoms in a circle to create a quantum coral. That means without tunneling, we could not even see atoms. Second example, alpha decay. You must have heard about radioactivity. Heavy elements like uranium and plutonium are unstable. They emit an alpha particle, 2 protons and 2 neutrons from their nucleus. According to classical physics, the alpha particle cannot escape the nucleus because there is a strong nuclear barrier around it. But the alpha particle tunnels through that barrier and comes out. This is the fundamental principle of radioactivity. Without tunneling, uranium on Earth would never decay, and we would have neither nuclear energy nor radiometric dating techniques. Now the most exciting question, if a particle can pass through a wall, can we teleport? Can we go from one place to another without traveling the path? The answer is Yes, but quantum teleportation is not like what is shown in movies. In quantum teleportation, we transfer the state of a particle from one location to another. This is a different process from tunneling, but both are wonders of the quantum world. In tunneling, the particle passes through a barrier. It does travel a path, but its presence on that path is not detectable. In teleportation, the mass of the particle disappears from one place and appears at another. This is based on the Einstein-Podolsky-Rosen, or EPR, puzzle. Scientists have already teleported photons. Chinese scientists teleported a photon from Earth to a satellite, 1,400 kilometers away. But teleportation of a human or any large object is not possible yet. So tunneling and teleportation are both unique properties of quantum mechanics. But combining them to walk through a wall is still science fiction. Now let me tell you what direction scientists are researching. Macro tunneling of large objects is not possible yet. But there are some interesting ideas in theoretical physics. First idea, superconductivity. Some materials become superconductors at very low temperatures. Electricity flows through them without any resistance. In these superconductors, pairs of electrons called Cooper pairs form, and these pairs move without any obstruction. Some scientists believe that if we can turn a large object into a superconductor, its wavelength would increase and the probability of tunneling might increase slightly. Second idea, Bose-Einstein condensate, or BEC. This is the fifth state of matter, formed at near absolute zero temperature. In BEC, billions of atoms come together in the same quantum state and behave like one giant wave. In 2019, scientists observed a cloud of BEC tunneling through a barrier. That cloud was about 10,000 atoms, a tiny but macroscopic object. So in the future, it might be possible to make a dust particle or a virus tunnel. But a human, for that, even theoretically, it seems impossible. However, the word impossible is very dangerous in science. There was a time when reaching the moon also seemed impossible. So friends, what did we learn today? 1. Quantum tunneling is a real phenomenon, not magic or imagination. 2. It burns the sun, runs your phone, and changes your DNA. 3. For a human to walk through a wall is mathematically possible, but practically almost impossible, at least for now. 4. Scientists are working on macro tunneling, and in the future it may become possible for small objects. Now I ask you a question. If you were given a chance to pass through any wall once, which wall would you choose? Would it be a physical wall, or a mental, social, or personal wall? Think about it. Thank you.